This lesson will cover relations and functions. The learning goal is to find a function and to understand function notation. Your success criteria is you can determine if a relation is a function based on its graph, table of values, or equation. So anytime you're looking at a relationship between two variables that can be quantified, you're looking at a mathematical relation. A relation can be expressed in four ways: words, equations, table of values, and graphs, just like how we can represent data. So to begin, for each scenario, we're going to provide a rough sketch and determine the name of the mathematical relation that can represent these relationships. So we're looking first at the height of a toy rocket launched from the ground over time. If we're looking at this, then we have height and we have time. Now, as a rocket is launched, it's going to increase in height very quickly in a short amount of time. And as it reaches the end of its burn cycle, it's going to slow down, reach the peak of its height, and then slowly come back down and increase quickly back down to the ground due to gravity. So this quadratic function best represents this relationship. So we have a quadratic function here. And quadratic functions are really good at representing the relationship of something that increases or decreases very quickly, comes to a maximum or minimum, and then returns back to where it was. However, if we're looking at the temperature of a cooling cup of water, that doesn't exactly work if we try to use a quadratic function, because the temperature is going to decrease over time. It's not going to return back to a temperature started at. So we need to look at a different kind of function that can represent this. So now we're looking at temperature and time. And if you think about this, let's say we boil a cup of water for tea. We're going to start off fairly hot, and the temperature will decrease fairly quickly. It will decrease really quick, and then start to slow down as it reaches kind of room temperature. Now, this function here that we've created, this is what we call an exponential function. An exponential function, these are based on the equations of any valued power of x, and it shows a relationship between two things that decreases or increases quickly and then reaches a kind of a constant value. Now that value is called an asymptote, or a horizontal asymptote in this case. As the temperature, let's say the temperature was increasing, getting close to room temperature, it won't exactly reach that temperature. It will very, very slowly get close to it, may not perhaps reach it. Now, it just depends on the context of what you're working with. Some cases you will reach, in terms of the temperature will eventually reach that room temperature, but in other cases it may not reach it. And that's where you use an asymptote to show that we're approaching a value, but won't exactly reach it. Now, if we're looking at the height of a rider on a Ferris wheel, we're looking at a very different graph for this. Again, we're looking at height, we're looking at time, and if you think about a Ferris wheel here, you're going to be going around the wheel. So your height is going to be increasing or decreasing and coming back to the same value over and over and over. And the best function represents this kind of scenario where you have a value that's kind of fluctuating. That's where we have a graph that looks like this. This is what we call a sinusoidal function. And these functions are represented through trigonometric functions, so sine, cos, and tan, where you have a fluctuating value over time. It's periodic, and it'll keep on will have varying levels of maximum and minimums and travel between them. Now, not all mathematical relations can claim to be classified as a function, but our three examples that we looked at all can. For every possible value of the independent variable x, there must be one value of the dependent variable y. So we call this a one-to-one relationship for x. So given the three sets of data below, determine which one can be classified as a function. So our first example here, we'll notice that we have x is -2, -1, 0, and -1. We have two x values of -1, which tells us that when x is equal to -1, y is equal to 3 and 4. This does not satisfy the one-to-one relationship for x, as each x value can only have one y value paired with it. If we look at the next example here, we have two y values of 3. So for instance, x is -1 and x is equal to 1 right here. This is a function because, well, yeah, we do have the y value of 3 equal to two different x's. The rule is that it's each x can only be equal to one y value. So here we're told that, for instance, x is equal to 1, it's only equal to 3. And when x is equal to 1 here, it's only equal to 3. That's fine. So this is a function. And this one was a relation. In our third example here, we have our three teachers, Mr. Sim, Ms. Matthews, and Ms. Merrick, and they are corresponding to different grades that they teach. Mrs. Merrick here, for instance, is corresponding only to 9. Mr. Sim is corresponding to 10 and 12, and Ms. Matthews is corresponding to 11 and 12. This can't be represented as a function. This must be a relation because we have, for instance, if we look at this as independent and this being dependent, the grade being tossed by the teacher, Mr. Sim is corresponding to two different values, and Ms. Matthews is also corresponding to two different values. This does not create a one-to-one relationship. So this is also a relation. What we're looking for is always that one-to-one relationship for our x value or independent value. So recall that each relation does have a domain and range. The domain is the set of all possible x values, and a range is the set of all possible y values. Now, if a relation has been graphed, we can actually perform something called a vertical line test. So a graphed relation, it must pass this vertical line test in order for it to be considered a function. Now what we do is we look at the graph, and if you can draw a vertical line anywhere and it hits the graph more than once, it is not a function. So for example, we're going to perform a vertical line test to determine if the relation is considered a function. It's as simple as drawing a vertical line. It can go anywhere on the graph. If you can draw a vertical line anywhere on the graph and it does pass the graph more than once, so here we cross twice, it is not a function. So this is a relation. We crossed twice, and this was a function. Guys, no matter where we draw the vertical line, it will cross only once. It's a vertical line test. Never use a horizontal line. It's always going to be a vertical line. Now the way this works is previously when we were looking at this example here, and we had x -1 and it is equal to two different y values, that would be this case right here. So for instance, when x is equal to, let's say, 3 here, it's equal to y as 2 and -2. So for you, perform a vertical line test to determine which of these relations are functions. Now we can also look at the equations themselves. So given an equation, we can check if it is a function. There's a few ways of doing this. Either you can graph the function or graph the equation and perform a vertical line test. In other cases, you can do this algebraically. So is the relation y equals -3 x plus q squared minus 4 considered a function? With our current knowledge, we can immediately say yes, and we can say yes because we know that this is the form of a quadratic function. is a quadratic function here. We know that due to its form. However, in other cases, we may not be familiar with the form. So for example, here we have x plus y squared equal to 10. Is this a function? Now, since we're not too familiar with this particular form, let's actually test this out. So for any relation, we can check if it does have, if it follows the one-to-one relationship for x to y. And the best way to check that is you just pick a value for x. So here I'm going to say that x is equal to 6. And then I'll substitute in. So I have 6 plus y squared equal to 10. And then I'm going to solve for y. So we'll have y squared equal to 4. And then we'll square root both sides. And we'll have y equal to plus or minus 2. Remember, when you square root a number, it is equal to its positive and its negative version, as 2 squared and negative 2 squared are both equal to 4. So here we just discovered that when x is equal to 6, y is equal to both negative 2 and positive 2. And thus has now filled the one-to-one relationship to check if a function or if relation is a function. So this is a relation. It is not a function. And again, to check that, you can even do it with the quadratic function we have above. Pick a value of x, substitute it, and if you get more than one y value, as a result, it is going to be a relation. If you get one single y value, it is going to be a function.